You're listening to Wildlife Control Consultant, where we provide research-based information on all things related to vertebrate pest management. Hi everyone, Stephen Vantassel here, Wildlife Control Consultant, bringing another episode of the Wildlife Control Consultant podcast. Hey, glad to have you on board. If you're wondering what we're all about, we deal with all things technical related to vertebrate pest management. That is all animals that have a spine, not humans, just animals that cause conflicts with human interests. And so we delve into some deep dives dealing with issues and topics that the average podcast simply can't address. So we're glad to have you on board. Still pretty busy, although some of my outside of the state traveling has finally come to an end. I have a couple of contracts I'm working on, but both of those don't require out-of-state travel. So I am getting one finished up on Tuesday, so I will finish my contract with that. So I'm kind of excited. Been keeping a pretty heavy pace, and so I'm really glad to kind of get a little bit of a break, and then I can finish off that other contract that I'm under. But nevertheless, I hope you're doing well. Spring is certainly coming, although in Montana we had a couple of feet of snow last week, but it's all gone now. So it's amazing. The weather in Montana certainly is rather bizarre. My recollection is we hold the record for the greatest difference in a temperature in a 24-hour period. I think it was something like 60 degrees or something. It was a staggering number. And so, but nevertheless, we were glad to have you here. And so you can see my website if you're looking for training materials that you'd like to purchase, or perhaps have me speak at your particular event, or do some training for your company, do some ghostwriting, perhaps create some training materials. Definitely reach out to me. You can reach me at wildlifecontrolconsultant@gmail.com, wildlifecontrolconsultant@gmail.com, and we'd love to chat with you, of course. So nevertheless, enough of that. Let's get this off the screen. So as I said before, I got a request from an individual looking for some up-to-date information, I think is how he was referring to it, on bromethalin, particularly the LD50. And I did a presentation on bromethalin. I called it sort of part 1. And this week, I'm going to kind of do a part 2 of some information that I've collected on bromethalin. And I think I have enough material probably to do a part 3. So in terms of up-to-date, it's hard to say exactly whether able to fulfill his exact question, but certainly last week's presentation delves into some of the issues of LD50, particularly what's called the lowest observable effect level, the low L effect level, and of course talked about how for cats it could be as low as 0.24, if memory serves, milligrams per kilogram, which is a really small amount. That's 1/5 of a millionth of a kilogram per kilogram. So if you have a 5-pound cat, you're looking at half a milligram could give you some effect, noticeable effect to a cat if a cat was exposed to that. Now, obviously, not every cat's going to have that level, but it shows you how low it can go. So I'd be careful using bromethalin around areas with cats, particularly if they're highly valued by the client. So something to think about. These are all the choices that we have to make as professionals, and it certainly is something that you have to be concerned about, not paranoid, right? We don't want to go the California route per se, but nevertheless, we need to be judicious and thoughtful. It's not just simply cookie cutter, right? You need to be having different tools for different areas, and so you need to be thinking about some of those consequences, because all rodenticides have risk. There's none that don't have risks. They all have risks to one level or another. It's just a matter of how we're balancing those risks and rewards based on our client. Okay. All right. Well, let me get this particular presentation up and running, and hopefully you can see that. So we're in bromethalin part 2. Now, you may recall bromethalin is a chemical that attacks sort of the mitochondria area of an organism. Mitochondria is the little engines that where we get our energy from, our cells, and it causes some swelling that can result in swelling along nerve tissue, leading to neurological effects. And so it's often treated as a neurotoxin. So it's affecting the neurological because it is a non-anticoagulant. So bromethalin does not kill on the basis of causing bleeding, much like many of our anticoagulants would, like bromadiolone, warfarin, chlorphenazine, diphethalone. Those are all anticoagulants. Bromethalin is in the category of a non-anticoagulant. So let's take a look at some issues related to this particular product. So it is fast-acting, relatively speaking. It doesn't take a long time for it to become absorbed in effect, and so that can be a good thing, bad thing, right? Depending if you want looking for a quicker knockdown. Sometimes your anticoagulants will take several days before the animals start feeling an effect. And of course, depending on how much the animal eats of bromethalin will determine obviously how quickly it dies. But notice in this particular PowerPoint slide, you can see that the effects of bromethalin can be felt by the organism within 24 hours. And so it is considered sort of a single dose rodenticide. Obviously, sometimes a mouse or a rat might consume more than one particular dose, but they can have sort of a single feed toxicity with this particular product. And it also has something interesting that's called a stop feed. That is, once the organism has reached a toxic level, consumed a toxic level, they no longer have a desire to eat more. So that's not always the case when it comes to your anticoagulants, okay? So something definitely to think about. So that's a plus. It means that we're not loading up a lot of our rodents with heavy doses of bromethalin, but you often don't need a whole lot of doses of bromethalin to get a toxic dose. Okay, so something to think about. So how does bromethalin relate to other products on the market, right? So here we're dealing with our theoretical 50-pound dog, and again, we're just going to assume, for the sake of argument, that this is a healthy, no issues with this particular dog. How much would it take to kill this particular dog? 50 pounds. And by the way, this is bait. This is not the technical. We're not dealing with pure bromethalin. We're talking about the formulated bromethalin inside of the product. So when you pull out that bait block and you put it inside your bait station, how many bait blocks would it take, or how many ounces of bait would it take to kill a 50-pound dog with an LD50? And your answer is, in terms of this particular chart, maybe around 5, right? So 3 to 4 ounces of bait, and you can see with strychnine, we're dealing with half an ounce. Strychnine is really, really toxic. So nevertheless, but again, that's the LD50. That is in terms of, half the dogs would live, half the dogs would die, right? And of course, if we're dealing with a dog that already has some underlying medical conditions, it could be less than that, right? So understand, when you compare that all to warfarin, for example, warfarin is a first-generation anticoagulant. Well, you're dealing with, 115 ounces of bait to kill a 50-pound dog. That's a whole lot, right? So you can see how warfarin is significantly safer on the part of a dog, because that's 100 ounces. That's the dog's eating pounds of material. That's certainly a lot, right? So keep these things in mind. Again, these are rules of thumb. These are helpful, but understand that the LD50 doesn't tell you everything you need to know about the toxic action of a particular rodenticide. So definitely keep that in mind. Sometimes it can give us a false sense of security, and sometimes it can give us excessive paranoia, right? And so you need to learn how to understand the LD50 as it relates to toxicity of products. Well, there was a subchronic study. Now, understand that when not me personally, but when researchers do toxicity studies with LD50, they're referring to what's called an initial dose, right? So they take a single dose of the rodenticide, and either force the animal to take it through a gavage type system, or they would feed it in, give it a feeding in one sitting. And so it's a single dose. A subchronic study, by contrast, is how does the toxicant work over time? So if the organism or the animal is eating the toxicant for multiple days. And so this is a subchronic study. So here we have a researcher that was taking rats and dogs and were dosing them at parts per million for 90 days. And they did it. You can see the blank there. The reason is because some dogs and rats, they dosed at 0. And other dogs, they wrote at 5 parts per million. And others were 25 parts per million, and then others at 125 parts per million, and another one at 200 parts per million, and that's dogs only. And what kind of results did they get? Well, what they found out was that there were no observable effects at 0, clearly, right, because there was no poison in the food at all. At 5 parts per million, even though the dog and rat was fed for 90 days, 5 parts per million on day 1, 5 parts per million on day 2, okay? And they did start getting effects, noticeable effects, at 25 parts per million. Now, the NOEL, if you're not familiar with that acronym, that's no observable effect level. So at 25, they did not see any effects. Once they started going into 125 parts per million for 90 days, they did see some effects. But notice I have the statement there, lesions observed. Well, what I mean by that is the researchers only noticed that there were signs of the effect of bromethalin when they did a necropsy on the animal. So in other words, if an animal survived to the end, they would still sacrifice them, and then they would perform a necropsy to see if there were any effects noticeable in their biology. Well, they did find that they were brain lesions from animals exposed at the 125 level for 90 days. And so now that wouldn't be noticeable by you or I in the field because we're not performing necropsies on dogs and rats, but it does tell you that there is some effect even at 125 parts per million. Now with dogs, they found that 200 parts per million, the dogs were beginning to show effects as well, okay, at the 200 level. So clearly you're noticing some issues somewhere between 25 and 125, but certainly at 125 parts per million, animals are going to have some level of effect when they're treated with this over a long period of time. Another study looked at days to death, and this is what's called caged choice test. This is where they would have rats, and they would put food in their cage, and one would be treated, one would not be treated, and they would have the option of choosing either the poison grain or the non-poison grain. And they were basically doing tests with different formulations: whole oats, wheat, cracked pinhead oats, and then oat flakes. And what they found you can see the active ingredient level, and this is at 0.01% for both wild rats and lab rats. And the reason why we distinguish those is because lab rats have been bred in captivity for generations, whereas that's not what we're controlling in the field, obviously. And wild rats obviously haven't been under that type of genetic control in a lab because they're free range and wild. What they found is that with the wild rats, they got an average mortality of 94 to 100%, depending on which group of rats they were looking at. And they found that bait consumption was anywhere between 30 and 71%, and that the death of wild rats was anywhere between 1.4 days and 4 days in this type of choice test. Now, choice tests are important because the rat has the choice of feeding on poison grain or unpoisoned grain. So we're seeing if they can notice any difference. Now, interestingly, on the lab rats, their average mortality was actually lower than that of the wild rats, which is kind of strange. and they were getting a average mortality anywhere between 83 and 100%. But they did consume more on average, and their bait consumption was 47 to 82%. And they tended to take longer to die, 2.1 days to 4.6 days to die. But again, they were using waxed block formulations with whole oats, whole wheat, and cracked maize. It's just corn. And wax block, typically wax block isn't as good, but for some reason they were certainly eating more of that in their choice test than the rats that were wild eating grain that wasn't encased in wax. So, all right, how about days to death for cage choice tests with mice? And so in this particular study, they were using grains again, both with canary seed, cracked oats, oat flakes, and with mice, they got a 92 to 100% mortality, and bait consumption was anywhere between 30 to 63%. So the mice really weren't hammering the bromethalin bait as well as we would like, but certainly effective enough to get at least a 92% level of control. And the mice were dying in under 3 days in this particular caged choice test. So how fast can mice die in the field? Well, 3 days, and as low as 1.5, depending on how much they're hitting your bait. Now, one of the issues that we're dealing with rodenticides, and that is the issue of half-life, because your clients are going to be concerned about, of course, secondary poisoning. And we normally don't talk a lot about secondary poisoning with non-anticoagulants. It's definitely an issue when we're dealing with anticoagulant baits. But believe it or not, there are issues with secondary poisoning with bromethalin, right? And so things are still being studied and learned about bromethalin and secondary poisoning, but it's clear, and we'll have some PowerPoint slides here shortly to talk about some of that. It does seem to be apparent that this does occur. And of course, there's going to have to be more research to try to explore what that level is, but it's certainly not innocuous in the sense that there is no secondary poisoning. In fact, that there does seem to be that there is. Now, what's the half-life? Well, half-life determines how long does it take for an animal that's consumed a poison to break their metabolism, to break that down to the half level. So let's say an organism like a mouse ate an ounce of bromethalin. That's an extraordinary amount, right? But just bear with me. Let's just assume the mouse ate an ounce of bromethalin. How long would it take for the mouse's biology to break that toxicant down so that only a half ounce was still present in their body? That's called half-life. Obviously, the shorter the half-life, the safer the rodenticide is, because ideally we would like to have a rodenticide that when a mouse eats it or a rat eats it, as soon as they're dead, the rodenticide disappears. That would be awesome, right? Because then there would be no secondary poisoning. Unfortunately, we don't have that quite yet as a general rule. So with bromethalin, it's found that it takes 5.6 days for the organism to eliminate half of the rodenticide in their system, and that's in the plasma. Now, there's different types of half-life. You have half-life in the plasma. Plasma is the liquid portion of your blood, so it takes 5.6 days for the half-life for that. But when it comes to muscle tissue or liver or maybe neurological tissue, how long would that be? Well, that could certainly be of a different time, because our body breaks things down in different parts of our body at different rates of speed. So with difascinone, it takes 15 to 20 days to get a half-life. With brodifacoum is a second-generation anticoagulant. You can see how toxic this is. It takes 120 days for an animal to get to a half-life of brodifacoum, which makes it's so persistent in an organism. That's why when a hawk or an owl or other raptor is feeding on a rodent and gets some brodifacoum in their system, it will accumulate over time. And then, of course, it takes so long for that bird to break that down, it can take months. And by the time, and if they get a new dose of brodifacoum, the clock starts all over again. Okay, so it's really, really tough. This is the disclaimer for Wildlife Control Consultant Podcast. Vertebrate pest control is an inherently dangerous activity involving risk of bodily injury to you, others, and/or property. Vertebrate pest control also involves legal issues, so be sure to always follow national, state, provincial, and local laws when using pesticides and/or other control methods when controlling pests. Wildlife Control Consultant LLC, Stephen M. Vantassel, or their affiliates are not responsible for your use of the information provided here. Always consult a qualified and appropriate professional before employing the information provided here.